Did you know that you can take Windows tasks that take hours and automate them down to seconds? With PowerShell, you'll unlock tools to boost your productivity, save you time, and allow you to take total control of your system. In this video, I'm going to be your personal PowerShell coach, walking you through everything you need to know, from the absolute basics to advanced scripting and automation. No programming experience? No problem. This guide is built for beginners, packed with simple explanations, practical examples, and real tips to help you learn by doing. By the end, you'll have the tools and confidence to automate tasks and make you look like a PowerShell rock star. Mastering PowerShell has become an essential skill for IT developers. In fact, it ranks as one of the highest paying technologies in the 2024 Stack Overflow Developer Survey. PowerShell is more than a command line interface. It is a versatile and powerful tool that can help you automate your repetitive tasks and streamline your workflows. But let's face it, learning a new technology can be incredibly intimidating, especially when you're starting from scratch. And this is your roadmap for learning where to get started on mastering PowerShell, because we're about to completely change how you interact with your Windows PC. So, grab a cup of coffee or tea and let's start building your mastery of PowerShell. Right out of the gate, you need to understand that there are two types of PowerShell. Let's break it down. Windows PowerShell comes pre-installed on Windows. It's built on the .NET framework, but here's the catch. It's Windows only, and it's no longer receiving any feature updates. In fact, it's slated to lose support in 2025. Then there's PowerShell Core. It's the new cross-platform PowerShell. And what that means is it runs on Windows, Linux, and Mac OS. And it's supercharged with object-based pipelines that make commands more dynamic and versatile than ever. What makes PowerShell Core different? Imagine a spreadsheet. Each object in PowerShell is like a row, with properties that are like the columns and methods, functions like sum. Unlike traditional text-based shells, PowerShell passes rich objects, making your workflows smarter and more efficient. We are diving into PowerShell. Are you ready to future-proof your skills? Stick around, because by the end, you'll understand why PowerShell Core is the tool for modern automation. PowerShell can be installed in several different ways, and each way is suited to support a different scenario. I'll be showing you how to install PowerShell two ways, using WinGet and using an MSI package. WinGet installs the same MSI package, but does it using a single command from the command line. WinGet is the recommended way to install PowerShell. You should watch this video where I walk you through getting started using WinGet to manage your software. Installing an application is very simple with WinGet. If you're running on a Windows 11 computer or Windows 10 version 1709 or later. If you're running on Windows 10, you can easily check the version of Windows by pressing the Windows key plus R at the same time. When the Run window opens, enter WinVer and press OK. If the version is 1709 or greater, you can install PowerShell 7. Enter the following command to install PowerShell Core. WinGet will check for the available application package, download the installer, and install PowerShell Core. I've already got PowerShell Core installed, but it should install on your machine. Click this link to download the MSI package for the latest release of PowerShell on the PowerShell GitHub repo. Find the downloaded MSI package in your Downloads folder and execute it to install PowerShell. Follow the prompts to complete the installation. I recommend adding it to the context menus when given that option. You should pause the video and install PowerShell Core. We will verify the release after installation. After installation, you should validate that the current release is installed. Open Windows Terminal. Click the Windows key plus X at the same time and select Terminal Admin to open it. After opening Windows Terminal, click the down caret next to the plus button at the top of the window and select PowerShell. This opens up a PowerShell terminal. Enter the following command to verify the installed version. It should return a version that matches the MSI package that you just downloaded and installed. PowerShell contains hundreds of commands, and these commands are called commandlets. Each command is named using a verb-noun pair, which makes them easy to find and understand their purpose or the thing that they do. I will be giving you a full demonstration about how some of these commands can be applied in your workflows and scripts. You're going to see a few key commands and topics that will help you discover how to get to know PowerShell and develop your command line skills. Get help is the primary command for exploring PowerShell commands, syntax, and examples right from the command line. It provides detailed information about other PowerShell commands, functions, scripts, and even workflows. You can quickly understand what a command does, its syntax, the parameters it accepts, and how to use it. Type get help followed by the name of the command you want to learn more about. It will show you all the information related to that command and includes a breakdown of parameters, inputs, outputs, and examples. You can include the examples parameter to get real world examples of how the command works in different scenarios. And if you want to have complete documentation for a command, adding the detailed or full parameter provides an in depth look at parameters, inputs, and outputs. To provide the examples and the full online help from the command line, PowerShell relies on local help files. You should download the latest help content from Microsoft servers. This ensures that you have the latest documentation available. Open PowerShell and run the update help command to download the newest available help files, and they will be downloaded to your local machine. Get command returns a list of every single commandlet, function, alias, application, or script that PowerShell recognizes. Think of it as your all in one resource for discovering what commands are at your fingertips. It helps you discover, filter, and understand the full range of commands available to you in PowerShell. There are several ways you can get using parameters and other commandlets that allow you to filter the commands returned. You can find the parameters that allow filtering for each command using the get help commandlet. The noun parameter allows you to filter commands related to a noun. Using this parameter will return a list of commands for that noun. This parameter does accept using wildcard characters, which expands the flexibility of your search. For instance, you can search for all commands where the noun part of the command name is location. PowerShell's piping feature allows you to send the output of one command to another to filter and shape that output further. Because the output is a .NET object, the properties are available to be selected and filtered throughout the pipeline. The object commands will be covered later in this video, but the output from the get command is being piped to the select object command to filter and shape that output. We are going to select the name and source and return a list of 10 commands that are unfiltered. Using where object command, we are going to get a list of commands filtered to only include commands whose noun is item. You can use the noun parameter on get command to return the exact same list. However, the demonstration of the piping feature is the relevant point that I'm trying to make here. The get member command is a really useful command. It allows you to discover what the output of a particular command looks like. This command returns the type, properties, and methods of an object. The output is returned grouped by type and includes the name, member type, and definition. You will use this output to determine what properties to include in the output of the command that you want to use. This comes really handy when writing scripts for automation to provide consistent results. The list of members returned for all commands include method properties and script properties. You can filter this list to only return properties by using the member type parameter. The output is returned grouped by type and includes the name, member type, and definition. You will use this output to determine what properties to include in the output of the command that you're using. About topics are detailed help articles built right into PowerShell, covering the fundamental concepts that you need to know. They are essential for learning the basics and mastering advanced concepts, explaining core ideas like variables, operators, pipelines, and even scripting best practices. You can get a full list of the topics available by using the asterisk wildcard character. It returns the list of all available about articles. Use the get help command followed by the about topic name to return full documentation on the command line about that topic. PowerShell returns a full description, all of the information about implementing the subject of the topic in your workflows, including examples. Each about topic offers a complete overview of the subject, breaking down complex concepts into understandable terms. Whether you're automating tasks or managing systems, the real world examples on the page show you exactly how to apply what you've learned. PowerShell Core provides a list of related commands that you can use. This helps you see how different commands and concepts are interconnected. Want to deepen your knowledge further? The About topic suggests additional subjects you should explore next. These recommended subjects guide you through a structured learning path that builds your knowledge step by step. PowerShell Core's About topics are your gateway to mastering this dynamic scripting language. These detailed, user friendly guides break down complex concepts into digestible chunks, helping you understand the nuances of PowerShell Core. As we've already discovered, the output of a PowerShell command are .NET objects. In most use cases, the output will be compiled using multiple commands and not really be in the shape that is needed for an expected use case, and will not be in the shape to fulfill the requirements of that use case. There are commands that allow you to filter and shape the output into your desired result. You can find those commands using a command and a parameter that you've already learned. Get command and the noun parameter. There are 10 commands returned for the object noun. We will be taking a look at 4 of them: select object, where object, group object, and sort object. These commands are part of PowerShell's object-oriented pipeline. They let you filter, sort, group, and select specific data from objects, making it easier to work with and analyze your data in just a few commands. First, let's break down what each of these commands does. Then we'll see how they work together in the pipeline. A popular real world use case is working with files, such as managing them or analyzing them for a report. We are going to be working with files in a directory to demonstrate how these commands can be chained together to deliver a summary of files grouped, counted, and sorted. Where object is the command that is all about filtering. It is like applying a filter to the rows of a spreadsheet. You can use it to include only the objects that meet certain conditions. We will start by filtering the files in this directory being returned by the getChildItem command. The filter asks for files where the name is like PDF to return all PDF files. You should always try to use the where object command as early as possible in the pipeline to reduce the amount of data that each subsequent command in that pipeline has to process. Select object is used to choose specific properties or columns from objects. It is like selecting specific columns from a spreadsheet. Select object lets you focus on only the data you need, making output clearer and more manageable. It is really useful when you're dealing with a lot of properties but only need a few. This command requires an input. This input comes from the output that is piped from the prior command. In this case, the where object. The select object command uses that input to shape it to only include three properties that are members of that input. It returns the name, length, which is file size in bytes, and directory for each file. As you can see here, where we return the name, length, and directory of that file from one pipeline. Piping.NET Objects in PowerShell elevates your scripting to new heights. It combines the best of object-oriented programming with the simplicity of shell scripting. Take your time and really explore piping to harness how it can supercharge how you automate and manage tasks. Group object allows you to group objects based on a specific property. This is useful when you want to see counts or group data by some category. Grouping is a great way to get a high level view of your data and spot patterns or commonalities. The naming convention for the files is intended to be able to identify the US state of the customer for which an invoice has been created. The naming convention will allow you to group and count the number of files by state. In future videos, we will be exploring PowerShell expressions. The group object command is using an expression to get the first two characters of the file name. This represents the state in our use case. Executing this pipeline will return a list of grouped files by state and the count of those groups. The sort object command does exactly what it sounds like. It orders your data based on specific properties. Sorting helps make data more readable and lets you quickly spot the highest or lowest values. Piping the grouped output to this command will give you the output that the use case requires. A count of the files by state and sorted in ascending order by state. Our use case is now complete, and using a real example of how using a few of the object commands can produce the data required for reporting on a particular type of file. PowerShell is a dynamic and versatile scripting language. It's designed specifically for task automation and configuration management. PowerShell's modular design allows developers to create and share reusable scripts, functions, and modules. Scripts, functions, and modules can all handle complex tasks like data processing, system administration, or even cloud management. Let's dive into what each of those are. Scripts are a collection of commands that perform a set of tasks. Functions are named blocks of code that perform a particular task. They can take parameters, return values. They are ideal for automating daily administrative tasks like backup and log analysis and system monitoring. They are perfect for breaking down complex scripts into manageable pieces. And modules are packages of scripts and functions and other resources that are bundled together. Modules help organize and distribute reusable code. Sharing code across teams and projects is the use case for modules. They can be imported into PowerShell sessions to extend functionality and create custom commands. Let's start with PowerShell scripts. In this script, we are searching a file system to get the name, length, date created, and directory for each file at the specified location. It will then save the file information to a CSV file, and that will be used to do an audit of those files. But first, we need to create some files so that we can demonstrate the use of our scripts, functions, and modules that we will be creating. We will now be creating a new directory named Files. When you've entered the command, create the directory. We will be creating a subfolder within that directory named Old Files. Now we'll add some files. The first file will be file 1 in the files directory. We will create another one called file 2 and a third called file 3. We will create one file within the old file subdirectory. You can see the files that we've just created by using the getChildItem command. Create a new empty script file and open it in Notepad by executing the following commands. I do recommend that you create a folder to store your sample scripts. I personally use a folder called Sandbox on the C drive. Once you've entered this command, execute it to create a new empty file called getLocationFileInfo. The PS1 file extension indicates that it's a PowerShell script file. Now, we're going to open that file in Notepad. You can use any editor of your choice, but everyone with a Windows machine has Notepad already installed. Execute the following script to open the file in Notepad. We are adding the code to the script file. In the first step, we are defining the highest level folder location of the directory in which we want to get file information from. Then PowerShell loops through each child item and gets the files, including all subdirectories. We then create an empty array that file information will be stored in. As we loop through each file and get the name, length, date created, and directory, and append each item, each file, to that array. We then define the current date time and use it to create a file path for the CSV file. The file info array is piped into the export CSV command as an input, and it is output to the path designated by the output CSV file variable. We execute the script file by using dot notation and designating the full file name from the folder in which it's saved. You can see the newly created CSV file in the files folder using the getChildItem command. We can then pipe the output of the file info file into the selectObject command to see the contents of the file. And now we have a static working script that can be run and will generate the file information for the files in the designated folder. Scripts are perfect for quick standalone automations or one-off tasks, but managing and using too many scripts can begin to outweigh the automation benefits they provide. Although you can use scheduling tools to automate their execution, the individual code blocks contained within them aren't reusable. One of the aspects of automation is that you can write code once and reuse it when you need it. If you get an error when running scripts, you may need to change the execution policy. A PowerShell execution policy determines the level of trust assigned to PowerShell scripts and configuration files before they are executed. It does not restrict the actions that a script can perform. It does help prevent untrusted scripts from running and minimizes the risk of accidentally running malicious scripts. Execution policies can be set at different scopes, and the policy with the most restrictive scope is effective. You can view the current execution policy by using the get execution policy command. And you can change the execution policy using the set execution policy commandlet. The remote signed execution policy strikes a great balance by ensuring that you're protected from running untrusted scripts, but places no restrictions on developing and executing your own scripts. It also allows scripts and configuration files downloaded from the internet to run if they are digitally signed by a trusted publisher. The set execution policy command must be run in an elevated PowerShell session. In other words, it must be run as an administrator. Suppose you need to run a script downloaded from the internet, but your current policy is set to restricted. You can change the execution policy for the current session without modifying the global policy. This will allow you to execute those scripts but not experience any errors. Functions are reusable blocks of code you can call whenever you need them. Unlike scripts, functions don't automatically run when the file loads. They need to be called explicitly. This is helpful when you have repeatable tasks that you might want to use in multiple scripts. Here's a brief breakdown of the components of a function. The function keyword is used to declare a function. It provides a function name. The param block is used to define the parameters that the function can accept. Parameters make the function flexible by allowing inputs. The core logic of the function is contained within its curly braces. And an optional return keyword can output results from the function. Functions keep things modular, so if you need the same task in multiple scripts, you don't have to rewrite code. Naming your functions should follow the verb noun naming convention and use an approved verb that can be found using the get verb command. The get verb command returns a table that lists all of the available verbs, the prefix, the group that it's contained in, and the description. As you can see here, the common verbs are listed at the top. These are the ones that are used the most often. Then there are verbs that are related to communications, and then data, diagnostic verbs, life cycle verbs, and security. These are the verbs that you should use when you are naming your functions and your modules. We will be getting to modules later on. We are going to break our script down into two functions that will be called in a separate script file. Converting the script to functions will enable us to modularize the code and provide reusability. Create the files by entering these commands. The first function will handle retrieving the file information from a specified location and return it as an array. The output of this function can be used by any script, function, or module that calls it. We're really upping the reusability factor. Open the file with Notepad using this command. Add this code to the file. It does the exact same thing as the script file that we created, but it receives a parameter for the file location. This is the location where PowerShell will search to get the files to retrieve the file information. It will populate the file info array, which will be used as an input for the second function. When you've added the code to the file, save it in the folder you created to house your scripts and exit Notepad. We are ready to create the second function that will export any array it receives to a CSV file. Not only will it be able to fulfill the expectation that the file information returned by the first function will be saved to a CSV file, it will also do the same with any input array containing any set of data. Again, we will be adding reusability potential beyond the original use case. Open the file with Notepad. Add this code to create the second function. It receives two parameters. One is an input array, which will be received from the first function. The second parameter is the output CSV file, which will output the CSV file. Two additional lines of code have been added. One, the getDate command is used to retrieve the current date time. Then that value will be added to the output CSV file to allow for point-in-time retrieval of file information. A good use case for this would be if you wanted to understand when new files were added to a particular file location. An audit could be done on a daily basis to determine what files were new since last audited. The script file will call both functions, passing them the file location and output CSV file parameters, and coordinating the retrieval and export of file information. Open the file with Notepad. The functions are being referenced in the script file using dot sourcing. This is not a best practice. Let's examine that further. Dot sourcing in PowerShell is a technique used to run a script in the current session context, allowing functions, variables, and other elements defined in a script to be available in your session after the script runs. This isn't a best practice for the following reasons. It impacts performance due to unnecessary memory usage from loading the context of a function into memory. Functions are loaded into the global scope, which could cause conflicts with existing variables or other functions with the same names. It's difficult to maintain because dot sourcing can lead to not understanding exactly where functions are being stored, which also can make debugging challenging. And it also imposes security risks when potentially executing malicious code because functions are external files. The best practice when using functions is to include them as part of a module. We will do that in the next chapter. We are simply demonstrating how functions are created and used within the context of a function itself. You could use dot sourcing in a very limited fashion if running them locally on your machine for very specific use cases. We are dot sourcing both functions, the get file information and export input array to CSV function. We are setting the variables for file location and output CSV file. Then we create a variable passing in the output of the get file information function. We then pass that array into the export input array to CSV function along with the contents of the output CSV file variable. When you've added the code, save the file and exit Notepad. Let's see the functions in action. Execute the file info script. After execution, you can get the latest file info file and load it into a variable. Then you can convert the contents of that variable to a CSV list and pipe it to select object command. It will return a table with the name, length, date created, and directory included in the file info file, all from the command line. Now that we've seen how to create reusable functions, let's talk about modules. Creating a PowerShell module allows you to encapsulate collections of related functions, scripts, or even commands into a reusable package that can be easily imported and used. We are going to be converting each of our functions into modules. This will allow the functions to be called as reusable modules when they are needed. Let's get started. Let's start by creating the module files. Modules should be saved in a PowerShell module path location. You can find that location using the PS module path environment variable. This variable stores all of the paths for modules stored across the different PowerShell types. You should create a folder with the same name as your module in the PowerShell module path location, and then save the module file in that folder. Or you can use the following commands to create the PowerShell module files. We are creating a list of the PowerShell module paths available on our machine. The contents of this will be placed in a variable, which will be used to select the item in the path list that we want to save our modules in. Call the variable to see the list. These are the paths on my machine. Arrays are zero based, meaning the first item in a list is 0, the next is 1, and so on. You should select the path on your list where you want to save your modules. I will be using the first item in my list, so I'm calling the module path array, passing in the index value of 0 because it's the first one, and then adding on get file information. That is the first function we'll be converting into a module. I'm defining that in a folder variable because in the next command, we're going to be creating that folder using the variable. Then we will create a new directory at that module folder path. The next step will be to define the module path. Using the module folder just created, we're going to add a PowerShell module file in that folder. The extension for a PowerShell module is PSM1. The full path to the first module that we will be creating. And using that path, we are now going to create that file. We have successfully set up a PowerShell module folder and a PowerShell module file. We will do the same thing for the second function and create an additional file to hold the contents of a new module that will replace the script file we used in the functions chapter. I will be pasting these in. After pasting them in and executing them, we now have our second folder and file created in the PowerShell modules path. And now we have created 3 folders and 3 files that will house all the contents of our modules. For the module files that we just created, we have to copy the function code for the first 2 modules to the files and convert the file info script to a module for the last module, get location file info. The first 2 modules will be the same as the functions we created earlier. Using the module path array, we can create variables for paths to each module file. We'll use those variables to open the files in Notepad. First, get a list of the modules we just created by executing this pipeline. This pipeline creates a list of folders created on the module path array where the last write time is greater than or equal to today. This will retrieve only the modules we just created. Now that we have the module variables, we can use them to open each file in Notepad at the same time. This will make it easy to edit the files to add our code. We will be adding the same code as we added in the functions chapter to the first two files. The get file information module is exactly the same as the get file information function. The only difference is we will be able to import the module and use it without dot sourcing. Add the code to the file and save it. The same holds true for the second file, export input array to CSV. This module, like the first file, does the same as the function. Add the code and save the file. The only real change that we will be making is to the get location file info module. We will modify the parameters, remove the dot sourcing, and make a small change to the output CSV file parameter. We will be using the file location parameter to ensure that the output CSV file is placed in that folder. Add the code and save the file. After all three files have been modified and saved, close Notepad. Now that we have our modules created and ready for use, we need to import them into the PowerShell session. Use the import module command for all three modules to load it into the current PowerShell session so that we can use them and see them in action. Run the get location file info module, passing in the file location and output CSV file parameters. You can get a list of files where the name is like file info, sorting it by the last write time descending, and selecting the first single file. This will populate a latest file variable with the contents of that file. Then, using the import CSV command, we can add the contents of the latest file variable and create a CSV list from it. Then we can select the output as an object and return it. We have generated a CSV file with a list of file information using the get location file info module. We've then created a variable containing the contents of that file using the get child item command. You have just created 3 flexible and reusable modules that can be added to any project. Import the modules into the PowerShell session and add them to any project where you need to add their functionality. I have some homework for you to enhance your learning. Using what you have learned in this video, create a new module. The new module should use the code that we just used to create the module files and folders in the PowerShell module path. The new module should create a new module folder and file. Add 2 parameters to your module that will allow you to set the module folder and the module path. And remember, you have to use an accepted verb when creating the module. Do you remember how to get those verbs? Let me know in the comments how you did. Were you successful? What challenges did you face? Do you need further help? Let me know. PowerShell Core represents a powerful evolution in modern automation tools. But like any sophisticated tool, its true potential is unlocked not just by knowing its features, but by applying them effectively. Whether you're automating routine tasks, managing complex systems, or developing robust scripts, these practices will serve as your foundation for success. PowerShell Core will notify you in your terminal when a new version is available. You can always check your current version by simply typing this command in your terminal. Updating to the latest version is as easy as using the WinGet upgrade command. Or you can visit the official PowerShell GitHub page and follow the download instructions. Always take advantage of PowerShell's built-in help system. You can use the get help command followed by any command to get detailed information and examples. It comes in handy when learning new commands or troubleshooting. Instead of using generic names for variables, parameters, functions, or modules, use something that is descriptive like name or current directory. This makes your code more readable and easier to understand for anyone with whom you share your scripts. Make your scripts modular and reusable. By breaking down your scripts into functions and modules, you can easily manage and reuse code. This not only saves time, but also makes your scripts more maintainable. PowerShell's ability to pipe outputs from one command to another is extremely powerful. Experiment with piping to combine commands for more complex tasks. Use the available About Pipelines topic that provides detailed documentation to understand everything about using this essential PowerShell feature. You can also access this from the command line using the get help command. You have now been introduced to one of the most in demand skills in tech. And remember, every single expert has started exactly where you are today. The key is start small, automate one task at a time, and before you know it, you'll be the go to automation expert on your team. By mastering these fundamentals, you're not just learning PowerShell, you're unlocking its full potential. Do you want to take your automation skills further and dive into the world of DevOps? I have a video dedicated to the roles that Git and GitHub play in DevOps. You should definitely check that out. If you're excited to learn more about PowerShell, I've got tons of tips, tricks, and tutorials coming your way. Do you have any questions or do you need further help? Drop me a comment below and let's get the conversation started. Thanks for watching and taking one more step in transforming your curiosity into expertise.